In this video, I am going to discuss about moving average method. Moving average method is a statistical technique used to analyze time series data by smoothing out short-term fluctuations and highlighting long-term trends. It involves calculating the average of a specified number of data points over a given time period and then using that average as a single data point to represent the trend for that time period. Moving averages can help identify trends, changes in trends, and potential turning points in time series data. They can be useful for smoothing out noise and making it easier to see the underlying patterns of data. However, they can also have limitations, such as potentially lagging behind sudden changes or outliers in the data. Just like for previous techniques, we are using the past data to forecast the future periods. Always remember when it comes to forecasting, higher the number of past data we have, the more reliable will be the forecasting. Let me explain the moving average technique. We can use specific number of points for the average. It can be any number 2 or above, which means we can consider 2 points, 3 points, 4 points likewise. These are the same datasets as the linear regression. For this method, we don't have any formulas. This is purely a calculation based method. Let's consider this for 3-point moving average. 3-point moving average. Let's consider this for 4-point moving average. What is this 3-point means? We are considering 3 points at a time, starting from the beginning. These 3 points. What we have to do? We have to take the average of these 3 points, which means 25.8 plus 33.7 plus 31.1 divided by 3 because we are taking the average. Then we have to consider the next subsequent 3 points, which are these 3 values. We again have to calculate the average. 33.7 plus 31.1 plus 38.6 divided by 3. Likewise, then we have to take the next subsequent 3 points, which are these values. Likewise, we have to repeat these calculations for all the data. So the average value will lie in the middle of these 3 values, which is here. For the first 3 values, the first average value will lie here. This is the first average. Then for the next subsequent 3 points, the average will lie here. This is the second average value. For the next subsequent 3 points, the average will lie here, because this is the middle of these 3 values. Each average value has a particular time period aligned to it. So we can easily draw a trend for this dataset. Let's say this is the graph will look like before the trend line. There will be distortions and seasonalities. With the 3-point moving average values, the trend will smooth out these variations, somewhat like this. If we can increase the points we are considering for the averages, this trend line will be much more smoother and will be close to a straight line. Now let's talk about the 4-point moving average method. Now we have to consider 4 points for the average. The first 4 points for the first average value. Then the next subsequent 4 values. Like previously we have to take the averages. Now we are taking the averages for 4 points. The issue here is the average value will lie in the middle of the considered numbers, which is here. This is for the first average value. Then for the next average value, it will lie here. So these average values do not align with any quarter. They lie between the quarters. Likewise, in order to take average value for a particular quarter, we have to take the average of these two values again. Then that average value will lie between here. So this value will align with the quarter 3. Likewise, the next average value will align with quarter 4 so that we can draw the trend line reliably for each time period. Let's do this example in details. Here I am going to do this example by using the 4-point moving average method. If we consider the 3-point moving average, it will be much easier. But the trend line will be not smoother like 4-point moving average. Since this is the 4-point moving average, we have to consider 4 points at a time. So we have to take the average of these 4 values. So the moving average will be 32.3. The position of this average value is very important because average value lies in the middle of the considered numbers 1, 2, 3, 4. So the middle of these 4 numbers will be here. So this average does not have a aligned quarter. What we have to do is we have to calculate the average again. First of all, let's calculate the first moving averages for this given data. So these are the 4-point moving averages. As you can see, we do not have averages for the first 2 points and the last 2 points. Because in order to have a 4-point moving average, we have to have 4 values. So do not calculate the averages other than having 4 points. For example, you may think considering these 3 values, you can get a value for this position. But that will be incorrect because we have to have 4 points in order to take the average. This is a characteristic of this technique. So don't worry about having no values for these spaces. Then what we have to do, we have to calculate the average again. So this will be the trend. This will be the moving average trend. Now we are going to consider two values at a time. Very important thing to know. Do not consider 4 points here again. So the average of these 2 points will be 32.3 plus 32.825. Remember, divided by 2 because we are only considering two values. So the average will be 32.5625. Likewise, now we can calculate for next subsequent 2 points for these two, for these two, and for these two. Now this average value will have a aligned time period. This will align with the 2010 quarter 3. The next average value will align with 2010 quarter 4. The other average value will align with 2011 quarter 1. Now we can reliably plot the trend on the graph because every average point has a aligned time period. This is why we did another average calculations so that we have a particular time period for each average value. This 4-point moving average method is also known as the centered 8 quarterly total. Also in this technique we can calculate the seasonal variations. For the additive model, we can calculate the variation by taking the difference between the actual value and the trend value. So the variance equals to actual value minus trend value. This is for the additive model. So this will give a plus or minus value. For the multiplicative model, we can calculate the variance by dividing the actual value by trend value. We should calculate variances for each time period. 2010 quarter 3 under additive model variance is equal to 31.1 minus 32.5625. This will give a negative value. So the variation is negative 1.4625 using the additive model. Now let's calculate the variance using the multiplicative model. 31.1 divided by 32.5625. So the variance equals to 0.955. This is a relative value. This equals to 95%. We can simply multiply this value by 100 and we can take the percentage value. Like we did in the linear regression, we have to calculate the average quarterly variations, which means we have to take the comparable seasonal variations and take the average, which means we have to take the averages of Q1 separately, Q2 separately, Q3 separately and Q4 separately. So there will be 4 comparable seasonal variations for a year. We can calculate the average seasonal variations for additive model as well as for multiplicative model, which means we can consider Q1 values for each year and take the average of it, just like we did in linear regression. Thank you for watching. See you in the next video.